Hello, Rams. Today we're going to go over the homework for Tuesday, April 20th. All right, the first problem, problem 1, comes from pages 21 and 22 in your notes involving dividing fractions. And more specifically, it's the part over here where we rewrite a multiplication problem as a division problem or a division problem as a multiplication problem. All right, the problem says, which of the following expressions is equivalent to 4/5 times 7/9? Well, we learned, okay, this is already a multiplication problem, so it's a little bit backwards from what you're used to. So when we're looking at if we had a division problem, which division problem would be equivalent? Remember, do we divide fractions? No, sir. We keep the same first number. We would have started with division and changed it to multiplication, but we use the reciprocal of the last number. Reciprocal means flip it upside down. So it would be, take that 7/9 and flip it upside down and make it 9/7. So which answer choice looks like that? That would be B. Okay. Problem 2 is from pages 53 and 54. It's more specifically over here about the models, okay? All right, number 2 says, which decimal represents the amount of the figure that is shaded? Well, if it was a 10 by 10 grid, you could just count the pieces, okay? And in this one, there are 10 pieces shaded, but there are not 100 total squares. And remember, percent is out of 100. So if there are 10 squares, for it to be 10%, it would have to be 10 out of 100. But if I count the squares here, 1, 2, 3, 4, 5, by 1, 2, 3, 4, 5, that means 10 out of 25 are shaded, not 10 out of 100, okay? So now I need to make it out of 100. 25 times 4 is 100, so 10 times 4 is 40. 40 out of 100 is 40%, okay? All right. Number 3 goes from pages 53 and 54 also, but it is more of the rules on this side of how to change a fraction to a decimal, okay? All right, Jesse is measuring and cutting a piece of wood that's 3 5/8 pieces of long. What is the decimal form of that? All right, first thing I notice that there's a 3 in the front here. Oops, sorry. There's a 3 in the front here, which means my first number for all of these should be a 3. So that's good. Now I can ignore the 3 if they all match, and I'm going to go over here and take my 5/8 and make it into a decimal. So how do I change a fraction to a decimal? It is always by division. So I'm going to top dog, right? 5 divided by 8. Okay? First thing is say 8 doesn't go into 5, but 8 goes into 50 6 times. 6 times 8 is 48. And I subtract and get a 2. So add a 0 and bring it down. 8 times 2 is 16. And I get a 4. So I can continue adding zeros. 8 times 5 is 40. Now, 8 doesn't go into 100, but it goes into 1,000. So anytime you're dividing by 8, you know you should have 3 decimal places, okay? So your first number, remember, was a 3. So it's 3.625. 3 and 625 thousandths. All right, your next problem goes from pages 99 and 100 in your notebook. It is not building a box plot, but it's using what we know in the box plot about finding the interquartile range. All right, so Marisol compiled a list of how many texts her friends sent in 1 week. What is the interquartile range? Well, first thing is always going to be putting them in numerical order. So that's what I'm going to do. I have a 50. I have a 71. A 79. And then an 85. A 92. 98. 114. And 125. So I have 8, oh, that was not a 125, that was a 128, sorry. I have 8 numbers here total, okay? So I need to find the median. Step 1 is always going to be to find the median. So smallest and largest. I'm actually putting it over these so that I can go back and you find the interquartile range. Uh-oh, I'm down to two numbers left in the middle, and it's 85 and 92. So my median is between those. Do I care what the median is? Not really. It doesn't matter for interquartile range. So my median just says I'm going to take this half, and I'm going to take this half, and I'm going to look at them separately, okay? So now I'm going to find the interquartile range of the lower half here. So that means the median. Okay, smallest and largest. Uh-oh, and now I have two numbers left as the median. I've got to find what's between them. So remember, I add them together and divide by 2. 71 plus 79 is 150. And when I do 150 divided by 2, I'm going to get 75. So this number right here, my Q1, I'm going to change colors just so it stands out here. My Q1 is 75. Okay, I'm going to go back to my blue here. Over here on the same thing, mark out smallest and largest. Oh, I'm down to 2 left. I add them together and divide by 2. 114 plus 98 is 212. Well, when I divide that by 2, because remember, 2 medians means I add them together and divide by 2, I get 106. So, right here, my Q3, that third quartile, is 106. So to find the IQR, remember that's our goal here. IQR is found by doing quartile 3 minus quartile 1. Just the distance between this space and this space. How long is that? That's where the box would be, right? So 106 minus 75 is just going to be 31. Okay, your answer there is 31. You don't actually have to build the box plot, but you do have to know all the steps in it, okay? All right, number 5. These notes come from page 61 and also 59 in your notebook because we're using 2 different skills here, okay? We're going to be solving order of operations and then taking that answer and finding the prime factorization of it. Okay, first thing when I'm doing this, I'm always going to write out my problem in a space. Oh, that was messy. In a space that I can do the work, okay? 4 times 2 plus 7. So I know parentheses always goes first, so it's an 8. So I have 5 squared minus 8 plus 7. Order of operations tells me I have to do exponents next. So 5 to the second power is never going to be 10. It means 5 times 5. That's 2 5s there. 25 minus 8 plus 7. 25 minus 8 is 17. Plus 7 is 24. You notice none of my answers look like a 24, right? Because there aren't any. The answers actually say, take my 24 and now put it in prime factorization. So I'm going to make a factor tree for the number 24. I just need to think about all the numbers that multiply to give me 24, and I circle them if they're prime. So 12 times 2. 12 is made up of 2 times 6. 6 is made up of 2 times 3. And now I'm done because all of these are prime. So what I have here is 2 times 2 times 2 times 3. Well, there are 3 2s, so that means 2 to the third times 3. So it's D. Okay, let us know when you get to class if you have questions over these. All right, the next one comes from pages 15 and 16. It's over classifying rational numbers. Know your journal. Use your notes. They're going to help you. All right. So which of these following numbers can be classified as an integer but not a whole number? Okay, so I'm going to do a little diagram here, okay? So if I look at all of my whole numbers, all of these are whole numbers. Okay. These 0, 1, 2, 3, 4, 5, they're all whole numbers. But if I look at all of these numbers on my number line, all of the actual numbers here, they're all integers. Now, this -1.5 is not, but I'm talking about the actual numbers that are on here, okay? Now, that -1.5 is actually going to be a rational number because it falls between 2 of the integers. Okay, anything between those will be the rational numbers also, okay? So I want to know which of these numbers, so if it's an integer but not a whole number, it's got to be left of 0, somewhere to the left of 0, but it's got to be one of those numbers, one of those counting numbers on there. So it would be -3. All right, your next one is area of a triangle. It's actually got a few steps to it, but you can find the notes for this on page 85 and 86 in your notebook. All right, so this problem says, what is the area of an equilateral triangle whose side lengths and heights, are 1/4 of the size of this triangle? So first thing I want to do is change my numbers. What is 1/4 of 8? It's 2. And what's 1/4 of 12? It's 3. To find 1/4 of something, I can divide by 4. Okay, now this is an equilateral triangle. To find the area of a triangle, I need 1/2 of base times height. Well, I don't know the base of my whole, do I know the base of the whole triangle here? Yeah, because it's the same as the side here because it's equilateral, okay? So I have 1/2 of 2 times 3. 1/2 of 2 times 3. So the first thing I would do is 2 times 3 is 6. And 1/2 of 6 is 3. So my area equals 3 feet squared. So it is D. All right, your next problem comes from multiplying and dividing decimals. It's pages 23 through 26 in your notes. Okay, it's got both steps. All right, this problem says Jennifer paid $275 for 10 golf classes. How much more will she have to pay if she decides to take 7 more classes? Well, that means we need to know the cost of each class, right? So I set up a ratio table. This is a proportion or a rate. Okay, so 10 classes cost $275. One class, okay, so I need to figure out the cost of one class. So how do I get from 10 to 1? I divide by 10. So then whatever I do to the top, I do to the bottom. So what is 275 divided by 10? Well, remember, when I divide by a 10, all I'm going to do is take my decimal that's hidden behind here, and I'm going to move it one place to the left. I'm going to go 1/10 of a space right there. So 27.5 is the cost of one class. And now I just need to go back and figure out 7 classes, right? I need to know 7 classes. So how do I get from 1 to 7? I multiply by 7. And whatever I do to the top, I do to the bottom. So I just take this 27.5 and I multiply it by 7. And I will get $192.50. Okay, check and see if you got that right. All right, problem 9 goes through pages 47 and 50 here, okay? All right, David earns $561.30 every 2 weeks. He deposits 1/3 of his earnings, 1/3 of his earnings into a savings account. How much does he save in 8 weeks? All right, so what I've done here is I went through and divided. I wanted to know 1/3 of it, so I divide by 3. So every 2 weeks, he saves $187.10. But I need to figure out how much he saves over 8 weeks. I'm not going to multiply 8 because that was for 2 weeks. I'm going to multiply by 4. And whatever I do to the bottom, I do to the top. So $187.10 times 4 is $748.40. All right, your last problem is page 27 and 28 in your math notebook. Okay, a mountain climbing team descends from a summit of Mount Everest at a rate of 282 feet per hour. Descends means he goes down. So it's negative 282 feet. Times 6 hours is going to give me negative 1,692 feet. Okay, think about it. You're breaking it up into 6 equal parts. Every hour he goes down 282 feet. Okay, 6 times be negative 1,692. Have a good night, Rams.